Hello and welcome back to Chapter 2. In this, we're going to dive a little more into depth on the atoms, the nuggets, the little pieces that make up Python. And then we're going to work through our first real program that has a sort of beginning, middle, and end. So here we go. A big part of any programming language is the syntax for constants. The nice thing about this, it's kind of instinctive. So like 123 or 98.6, numbers, both integer and floating point numbers, we've been using these on calculators. They make a lot of sense to us. The kind of constants that are a little bit different are things like string constants. So quote, hello world is a string constant. And we use that so that our program can say nice things to people that are using our program. And so we call them constants because they don't change, but it's kind of obvious. Constants. It's just a piece of the language. So that's a constant. What else? Variables and key and reserved words. So the other thing other than constants are reserved words. And as I said in an earlier lecture, these are like dog language. Blah, 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 class, blah, 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 del, blah, 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 else, blah, 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 lambda. So these are words that when you say them to Python, Python expects them to mean exactly what Python wants you to mean. Now, why is this special? It's actually kind of instinctive. It just means don't use these for other things. Don't name functions, don't name classes, don't name variables. Places where you get choices to use words, don't use these words. And most of them aren't too big of a problem. I don't know, maybe break or in or from maybe. Some of these you might naturally use. Most of them are kind of weird enough that you're probably not going to use them as variable names. And so the third atom basically is variables. And you get to pick the variable names. And it's a little weird that you get to pick variable names, but you'll get used to it. And so variable names are places where you're asking Python to allocate a bit of memory and stick something in it. And you're choosing the label. And so if we take a look at this, when we have this assignment statement, and remember that assignment statements always have a direction, right? Think of these equal signs as having an arrow on them. In some languages, I saw a language that uses kind of an arrow, that uses a less than and a dash as the assignment. I'm like, that's how it should be. Because equal confuses us, because equal means something different in mathematics than it does in Python or other programming languages. So to look at this very first statement, what we're really saying is it's a pretty complex statement. After a while, you'll just use it. Python, find us a spare piece of memory somewhere and give it a label of X and put 12.2 in it. And remember that. Remember all that stuff. That's one of the things that Python does for us. It remembers stuff. Then we go to the second statement. It says, oh, hey, Python, find some memory, some spare memory that you got laying around, label it Y, and put 14 into that. Okay? And so that's how these things work, and you chose X and you chose Y. Now, if we keep on going in this code, and now we have another line, and we say, oh, hey, X, wait a sec, I already told you about X. X already exists, so don't go and grab any new memory, but stick 100 in that. So 100 goes in, and it wipes out the old value. So that's what happens. That's when this sequence starts. This happens first, second, third. And so the third thing is the last thing, and so X ends up with a residual value of 100 in it. So that's kind of variables and assignment statements. You have some naming rules. You can start variable names with letters or underscores, although we avoid underscores because Python tends to use underscores for its own internal purposes. And the rest of it can be letters, numbers, and underscores. And it's case sensitive. But we don't want you to depend on that. So spam all lowercase, spam with one uppercase, and spam, these all are different variable names. But you're not doing anybody any favor if you think that's being clever. We tend to sometimes use uppercase to signal things, which we'll talk about later, but we tend to use mostly lowercase. Some applications use what's called camel case, which is a mix, but you tend not to depend on the fact that these are unique because you really are misleading the person who's reading your code. But we have some good ones, spam, egg, spam 23, numbers are fine. It's fine to start with a underscore. It's bad to start with a number. It is bad to start with a pound sign, although that turns into a comment. And you can't use characters other than letters and numbers in the variable. And so those are all good variable names. Now we lead these things into sentences or lines. And so these things, this is just another sequence of code, and it shows how you can also use a variable on the right-hand side. So put 2 in some memory and label it X. Pull that 2 back out and then add 2 to it. So this little thing here becomes 4, and then stick 4 into X. And then this is a print function. And the way functions work is they are the name of a function followed by a parenthesis, followed by another parenthesis, and then you can print something, what you want to print. And so this causes on some output 4 to come out. So print is the function that you call to cause output. Now, I emphasize that one of the key things about variable names is that you get to name them. And we have a technique called mnemonic. I think I pronounced that right. And the idea is that when you choose a variable name, you should choose a variable name to be sensible. And Python doesn't care whether you choose mnemonic variable names or not. And the name that you choose for a variable does not communicate any additional information to Python. Okay, so when you're a beginning student, sometimes if you use variable names that are too good, it's confusing. So you'll notice as I write, especially in these first 2 chapters, some of my code uses really dumb variable names and some of them uses really clever ones. So I go back and forth to emphasize to you that the name of a variable, as long as it's consistent within the program, doesn't matter, and Python is perfectly happy. So here is a little code. It's 4 lines of code. And start at the top, run this line, and that says find a little piece of memory and label it that thing and stick 35 in it. Find a little piece of memory, label it that thing, stick 12 in it. Pull that first thing out and pull the second thing out, multiply them together and pull them into yet a third variable. If you look at these things really closely, they're all unique and distinct, and you do have to look at them very closely. Then you print the third thing out. And Python loves this code. Python thinks, great. I don't know why you picked those variables. I do not care. All I care is that they're unique. Python really has no opinion about these variables. But if you hand this code to a friend and you say, what is this code doing? They're like, why did you pick such insane variables? Because I have to stare at it and like, what the difference between like these 2 things is just the letter Z and the letter P. So this one we're printing the P guy out, and this time we're pulling the Z guy out, right? And these 2 just have a difference of those letters, I think. And you could do it. Python loves this stuff. To Python, this is perfectly understandable code. To human beings, it is not perfectly understandable code. So like people aren't going to like you, but Python is going to be very, very happy. I can't draw a happy snake, otherwise I would draw a happy snake. So this is tacky, bad, not friendly. So let's make it a little more friendly. You could choose variable names. To those, Python looks at these 2 things as like, those are the same. They're totally the same. Python doesn't care. But now we can look at it and go, oh, I see. The first variable is A, and we're putting that A thing there, and the second variable is B, we're putting the B thing there, and then we're multiplying it, put them in a C thing, and then we're printing the C thing out. That's pretty nice. So this is a little better, right? At least we can parse it and read it and understand what the code is going to do without having to check to see if these 2 characters are the same or different. So that's better, but it's not mnemonic. Okay, mnemonic means that we choose a variable name that makes sense for what we're using it for. Again, the variable name and Python looks at all these 3 things as the same. All Python cares is that this matches this matches that, and that matches this. But humans are much happier. Humans are much happier. Now, we understand mentally that the first variable, 35, was the hours. The second was the rate per hours. And then we computed a pay and we printed it out. So this is really understandable. The problem is for beginning programmers, it sometimes is too understandable, right? It's too understandable, right? Huh? Python knows about payroll? Because if I name a variable hours, shouldn't Python know that that means hours? And if I name a variable pay, does that mean that Python knows about this? And the answer is no. Python treats all these three as equal. Python doesn't look at the name of your variables and think, hey, you just had a bug, right? So what if, for example, I rewrote this code and I said hours times hours? And it's like, wouldn't Python say, hey, that doesn't make sense. Why would you even multiply in a payroll calculation? Why would you multiply hours times hours? And the answer is Python will happily do it because it's not looking at those words. But a human being who's trying to understand what your code is or trying to help you when you're writing code, debug your code, will be very thankful that you chose good names. And now I can look at your code, and if I see you say pay equals hours times hours, like, why did you multiply hours times hours? Didn't you really mean to multiply hours times rate? So mnemonic variables are only for humans. We will later see things that will confuse you when I name one variable friend and another one friends. And you'll be like, oh, so Python understands plurals. And the answer is no, Python doesn't understand plurals, okay? It's really helpful to read stuff so that when something has more than one thing in it, you might maybe use a variable that's got a plural in it. So, okay. Enough about that. I hope I made my point. These are all the same to Python, but human beings certainly prefer the second or the third. And so, but be careful. After chapter 10, you'll start using mnemonic variables and it won't be a problem. But in the first few chapters, you have to worry about it. So as I mentioned, assignment statements basically are not like mathematics. Equal sign means equality. Assignment statements means arrow. And the key thing is you can almost think of this as like there's a little wall there, and it completely computes this expression. This is an expression on the right-hand side, gets that down to a single variable, and then writes it into the variable, into the memory location. And that's why it's possible to have the same variable on both sides, because this side happens first, ignoring this side, and then once this side is done, then it actually puts it into that other side. And so if, for example, x before this statement started had a 0.6 in it, it's like firewalls this part off and it computes this part here by pulling the 0.6, the old value of x, doing the computation, running through the things, getting the new value, and then after it's got that new value, then and only then does it store the 936 into x, and that overwrites the 0.6 that was in x, okay? And so one side finishes, produces a result, and then it can overwrite. It doesn't mean you have to put the variable on both sides, but it's why you can put it. And so sometimes we'll say something like x equals x plus 1, and that's our way of adding 1 to x. And that's because whatever x is, maybe x is 6 or something, this becomes a 7, and then the 7 goes into x, and then it overwrites it to the 7. We call this increment. We'll see this soon. Okay, but that's why you can put the same thing. Now, in mathematics, x equals x plus 1 makes absolutely no sense, but in programming, it is one of the more common things that we do. Okay, so that gets us through variables and constants, and now we're going to talk a little bit more in detail about expressions. So welcome back. Now we're going to continue on the right-hand side of assignment statements and talk a little bit more about some complexity about what you can do with these expressions. So all programming languages have various operators where you say, x plus 1 or x minus 1 or something like that. These operators historically come from the kind of characters that were on computer keyboards in the 1960s, literally. These things called teletypes came from the end of World War II, and they had a certain set of characters. And we were going kind of from mathematical character set, where multiplication is a big cross or a dot in the middle, and exponentiation is raising a little tiny number above it. And we just couldn't represent those on these really rudimentary key punches or rudimentary terminals. So we had to map mathematical formulas and functions into what could be done. And so those keyboards from, 40 years ago, 50 years ago, they had a plus on it, so plus is a plus. They had a minus on it, but multiplication, which is normally cross, is star, and division, which you can't put things on top of one another, so you just made a slash for division. And raising to the power is double star. Now, the remainder operator is something that's not typically on calculators, but it's really important for computers, and we'll take a look at this. So the addition operator, pretty straightforward. I've kind of been using that without even talking about it. The multiplication and the division. So this is 5,280 divided by 1,000, which gives me 5.28. But the one that's probably the most interesting is this modulo or remainder operation. And so the way the remainder operation works is, in particular if this is an integer, is it does the division. So it's almost like a division, j divided by 5, but instead of giving the quotient, this is the quotient, it gives the remainder. So 5 divided by 23 is 4 remainder 3. The 3 is what you get back. Now you might ask yourself, why is this useful? So one of the ways to make this useful is to pick a large random number and then use the modulo operator, the remainder operator, with 52, and then you end up with a number between 0 and 51, and then you can pick a card. So you can take a random number, but you modulo at 52, and now you can have a random number that is a card. Or if you want to roll a dice, you make a big random number and you take it modulo 6, and then you can it tells you what side of the dice. So like games and stuff, there's other situations where you can do even and odd calculations, like is this an odd number, an even number, divide it by 2 and see what the remainder is. And so this whole notion of the modulo operator, it's really useful in some situations, and so that's why we obsess about it a little bit. The power operator, this is like 4 times 4 times 4, which is 64. So those are the numeric expressions. Now, these also have an order of evaluation, and the way it works is in mathematics, there's order of evaluation. There are some operators that are more powerful than other operators. And you can always, if you're clever, just put parentheses in. And most programmers always put parentheses in. So if I was writing this line of code and I want it to be friendly to you so that you could read it more easily, I would simply put the parentheses in for you. So I'd say 5 to the 6th power goes first, then this 4 divided by that goes next, then this 2 times 3 goes next, and then we evaluate the rest of these things left to right. So I just added the parentheses that are the same. This is exactly the same as what it would be without the parentheses, because this happens first, this part here happens second, this happens third, and then all this other stuff happens fourth. So there's an order. But we're going to teach you what the order is if you weren't going to use parentheses. So the rule is parentheses override everything. Exponentiation is the most powerful. Multiplication and division and remainder are equal. They're the next most powerful in addition and subtraction. And then when in doubt, you just go left to right. So if there's a bunch of additions, you just go left to right. Or if there's an addition and subtractions and a bunch of stuff, you go left to right. Okay? So this is a classic exam question on computer science homework that you just say, okay, what does this evaluate to? Now, of course, if you have Python, you just type it in and it tells you what the answer is. But so the way I used to do these back in the day when I was doing these homework is I would write the expression down on a piece of paper, and then I would look through it and I would figure out what the first thing was, and I'd be very careful about this. I'm like, okay, exponentiation happens first, so I'll do the 2 to the 3rd power, which is 8, and then I'll rewrite the whole thing, 1 plus 8 divided by 4 times 5, and then I would forget about this one and I'd look here and go like, okay, what's the first thing here? Well, 8 divided by 4 is the first thing there. So then I'd be like, oh, 8 divided by 4, well, that gives us 2. In this case, it gives us 2.0. And then I have 1 plus 2.0 times 5, and I look, and that's the next one. So that ends up being, actually, this ends up being 10.0, and that ends up being 11.0. And that's why this prints out 11.0. And so if there are no parentheses, you can figure out. Another kind of exam question is to ask what the parentheses would be. So the exponentiation happens first, the division happens second, and then actually you'd put another parenthesis because that result is multiplied by 5. And so that's another way to kind of answer the same question, is say put the parentheses in where they belong. Like I said, parentheses first, power second, multiplication third, addition, and then left to right. So when you got nothing but addition and subtraction, you go left to right. When you got nothing but multiplication, division, you go left to right. Start with the leftmost one. Sometimes it doesn't matter, but in addition and subtraction, it generally doesn't matter. But in multiplication and division, it can matter left to right. Okay, so we've been talking about variables, we've been talking about constants, and we've been talking about expressions, but we also have constants that are integers, we have constants that are floating point numbers, and we have constants that are strings. And we can manipulate these. And Python carefully tracks not only what the value in a variable is, but what kind of a value it is. So is it a string? Is it an integer? Is it a floating point? And sometimes this makes a difference. And here's a little example code. We have this plus operator. And the plus operator is looking at its two operands, 1 and 4. It's like, oh, those are integers. I know what to do with integers. That means addition. And so it adds this to be 5 and then sticks it into DDD, and out comes 5. On the other hand, we can actually use this same plus operator concatenating strings, because the plus operator looks to its left, looks to its right, says, oh, those are strings, and I know what you mean. I think you mean to concatenate this. And so then we end up with hello. The space is very carefully constructed right there because the plus doesn't add a space. So this ends up being hello space there, and that little space is the space here. And so Python knows the type of, in this example, these are all constants, but it knows the type of constants and it knows the type of variables, and it can do very different things. And it can blow up and be unhappy, as we'll soon see, based on the type of things. So here we have an example of something that's unhappy. So I have now concatenated hello in there, and then Python's perfectly happy to do that, and then I stick that in EE. And now I say I want to add 1 to it. And it looks to its left, looks to its right. This is a string, and this is an integer. And Python says, I don't know how to do that. Python could know how to do it, but it's chosen not to know how to do that. And so you get the dreaded traceback. And traceback is like syntax error. It is Python telling you, it's not Python telling you that you're a bad programmer or that you're never going to be a programmer or that you're completely unsuitable for a programmer. What Python is saying is, I, Python, am lost. You told me to do something I don't know how to do. You need to go remember what it is that I'm capable of doing as Python. Please come back and fix it. It also means that the program stops, meaning that if you're in a multi-line script and you're doing a bunch of stuff and there's a traceback here, the code after that quits, okay? And that's because you've hit this line that Python is lost, and Python is loath to continue. Now, we'll see in a bit that you'll be able to force it to continue if you want, but because you said something that Python didn't understand, it just quits at that point. And traceback, line 1 in this case, tells you where it is that this thing blew up. And so this looks like nasty gibberish, but after a while, it won't take you long at all to just relax, look for the word traceback. That means Python quit somewhere. It tells you where, and then you look a little bit farther, and it tells you what's wrong, type error. It's unhappy with the type, and it's still referring up to this line of code. It says, I can't convert integer objects to string implicitly. So it's like you have told it to do something, combining a string and an integer, and Python is like, I am lost. But I'm giving you as much clue as to how I got lost, what got me lost, where I got lost, where I got lost, and what caused me to get lost. And Python is trying as hard as it can to clue you into what's going wrong. So don't look at this as like bad. Look at this as like, oh, I've not quite communicated to Python the way I want to communicate. There's a way to solve this. There's a way to do something here. And so if we take Python and we think about Python and say, hey, you're so picky and you blow up if I do the least little mistake on types, like help me out here. And so it turns out that Python has a built-in function called type. So again, it's type with parentheses. Function calls have parentheses on them, and we pass something in. And we're like, hey, Python, tell me what the type of the variable EE is. And then Python prints out, oh, it's a string. What is the type of the constant, quote, hello, quote? That's a string. What is the type of the constant 1? That would be an integer. And so Python keeps track of the value of variables and constants, the value and the type of it. And so we have to kind of manipulate this and be aware of this as we move forward. And so there's several types of numbers that we've already sort of been implicitly playing with. Like I said, you can give a variable to type, or you can give a constant to type. Variables and constants that don't have decimal places are integers, what are called integers, and variables that have decimal places are called floating points. Even if this was a 98.0, it would still be a floating point. As soon as you put the point there, then that means it's a floating point. They are represented internally differently. Floating point numbers have a greater range than integer numbers, but they are not always as precise as integer numbers. So floating point numbers have more range and less precision. So integers are perfect, but there's a limit, like 4 billion or 4 trillion or something. There's a limit. Don't worry too much about that. There is a choice that you make. You tend to use floating point numbers for things like temperatures or speed. Turns out that you don't use floating point for money. You don't use it for money, even though in our first examples we'll be bad and we'll use it for money. But shh, don't tell anybody that I'm using floating point for money. If you want, you can play with floating point and start finding some things where money goes bad. Okay, there's actually a number of different movie plots that have to do with computer programs that use floating point for money. I think Office Space is one of them that I particularly like, but there's other ones as well. Why you don't use floating point for money. I kind of got off track on that, but that's okay. So, we also have a set of built-in functions that can convert from one type to another. There's float, there's int. And so float is a function. It again has parentheses. We pass in 99. So as this expression is being evaluated, it has to call float. It passes in 99, and then what comes back is 99.0, which is a floating point representation of the number 99. 99 and 99.0 are not the same. This is a floating point number. So when this addition happens, it produces 199.0. So that is a floating point 199.0. You are force converting by putting this, calling float, you are force converting that to a floating point number. If we look at like I is 42, we ask what type it is. Well, that I is an integer. We can take a variable and pass it into the float function and get back 42.0. That 42.0 comes back. And we say, what kind of thing is in F? Well, F is a float, right? So you can see how we're manipulating the type of things and controlling it. And anytime we get a little confused, we use the type function and say, hey, what's going on here? Why don't I understand what's going on here? Integer division is something that actually changed between Python 2 and Python 3. It's one of the bigger changes, the bigger non-upwards compatible changes between Python 2 and Python 3. And so this I'm just reviewing. There are some things that were different in Python 2. So 10 divided by 2, even though those are both integers, produces a floating point result. This doesn't make much difference if these are evenly divisible, but if they're not evenly divisible, it makes a big difference. So 9 over 2 is 4.5. Think about like if you put in 9 divided by 2 in a calculator, you wouldn't expect it to say 4. And in Python 2, it said 4. It actually truncated. It actually threw this bit away. But in Python 3, it just automatically converts divisions to floating point, and so it works out quite nice. Okay, so 9 over 2 is 4.5. In Python 2, this used to be 4. And then 99 over 100 is 0.99, exactly what you'd expect in Python 3. In Python 2, that was a 0. Why? Because it truncated. It didn't even round the numbers. It chopped them off. So this was really quite a silly artifact of Python 2. In Python 2, if you get stuck in Python 2, you just use floating point numbers. And once either side of the division or any other operation is a floating point number, then the calculation is done in floating point. So if it's floating point input on either side, then it's floating point output. And this is what we used to have to do kind of in Python 2, is force things to be floating if we're doing divisions. It wouldn't hurt to do it in Python 3, but now integer division in Python 3 makes a lot more sense, thank heaven. Okay, string conversions. So if we read data, which we're going to see in a second, from the outside world, it comes in as strings. Whether reading from a network or from a database, we tend to get these things as strings. And so what we're showing here is a a string value that's 123, but it's not really 123. It's 3 characters. It might as well be A, B, C. So 1, 2, 3 are the first 3 characters. So we take this string constant, we put it in there, and we say, okay, what kind of thing is in there? It's a string. And if we try to add 1 to it, as we saw before, you add a string and an integer, and Python gets really unhappy. Can't convert int object to string implicitly. But what if we know that inside of this string are actually digits, and we want to get an integer representation or a floating point representation of that? Well, in that case, we can call the int function or the float function, passing in a string and getting back an integer. So this basically reads these characters, the 1, 2, 3, and goes, oh, that's 123, and gives us back 123. And we say, what kind of thing is in there? Well, now in ival, there's an int. Now I'm being mnemonic here. I'm remembering that this is an integer and this is a string, but Python doesn't care what I name my variables. Remember, Python never cares about what I name my variables. So if I start naming them conveniently, don't all of a sudden think that everything that starts with the prefix I is an integer and everything that starts with the prefix S is a string. It'll be a number of lectures before I stop reminding you of that. So, ival ends up with an integer, the number 123, and now we can indeed add 1 to it because it's an integer, and Python's happy, and out comes a 124. So this works pretty well, unless the string that in question has no digits. So there are no digits, it's going to blow up. It's like, whoa! Now, let's read it. Traceback means I quit. Where? Line 1. It's always line 1 because we're in this interactive environment. So, but if you were in a script, it would tell you what line it is. And then it says invalid literal for int with a base 10x. And that's like, okay, it's not working very well. And so, say, oh, that's an invalid literal. And again, we'll find ways to cope with this in later lectures. Okay? Now, how do we get data from the outside world? So this is the keyboard. Eventually we'll talk to networks and databases and files, but right now we want to take the keys from the keyboard and get it into a variable. So we have another function, a special function, the input function. And when Python comes running in here, it starts the input function, and the parameter to the input function is what's called a prompt. It prints out, who are you, and then it waits. And then we type into the keyboard, Chuck, and then we hit the enter key, and then it takes this string right here, and then it puts it in this variable right here. It is a string. Even if I typed in 1, 2, 3, 4, it would be the string 1, 2, 3, 4, not 1,234. Okay? And so that is the way. And so this program at this point pauses until we type and we hit the enter key, and then it takes that line of input, including spaces, whatever I've typed, and puts it in that variable. And then the program continues. And in this case, it just prints out welcome, comma, and then the contents of the variable NAM. And in this case, this space right here that you see between welcome and Chuck, that is caused by this comma. So we mostly seen printing one thing, but you can have as many things as you want with commas in print, and every comma adds a space, and so it's kind of friendly. If you wanted to, you'd have to concatenate these things together to eliminate that space. But most commonly, you're printing out a list of things, you probably want spaces between it. Okay? So that's how we read input. Up next, we're going to combine all these things, and we're going to make our very first program that does actually something useful. So we'll see in a bit. So now we're going to combine everything in the previous lectures, and we're going to actually make our first program. So before we make this program, we need to talk a little bit about documentation. We talked about mnemonic variables as a friendly thing for humans. Another thing that's a friendly thing in programs for humans, and you will tend to realize that the human that you're being friendly to when you're writing code and you're doing it well is yourself. So good variable names are going to help you a lot. They might help your teaching assistant, but they're also going to help you. And comments. Comments are a way for us to add text that's ignored by Python to our programs. And so it's a great way to give a little idea what's going on in code. Maybe there's a couple of lines coming up that are 10 lines long that's a little complex, and you want to say, oh, all this is really doing is reversing the order of these two things, or who knows what. or you might document who wrote the code, and you can actually just take a line of code and put a pound sign in front of it, and then instead of deleting the line of code. And sometimes you do that for debugging. You add debugging code, and then when you don't want the debugging code, you just put a pound sign in case you want to take the pound sign out to turn the code back on. So I use it as a way to turn it off and on lines of code. So here is our word frequency that we keep coming back to. And what I've added here is I've added 4 comments. I've added comments that basically help us understand what's going on. And remember, I call these like paragraphs. Our first paragraph has human readable code, human readable text. Get the name of the file and open it. That's what's going to happen in the next 2 lines. These next 5 lines are count the word frequency. Maybe I should say make a histogram. So make a histogram. And you can just read this. And so, again, don't think of this as like the teacher's telling you that you got to write comments. Think of this as like, I'll write comments so I remember what I was doing here. Why did I write this code? So write the comments to help yourself out. And now here, the last thing, we're all done and we're printing the stuff out. Okay? So that's comments. It's an important part of documenting your code so that you can figure it out later. And again, the human who's going to like you for doing all this stuff is you. Right? So you, this is you, and you're giving a gift to the future you. Right? So you are writing comments so that the future you can read the comments. Because in a day or a week or a month, you won't quite remember what you were doing. So go ahead and write comments. But don't write them because I said so. Write only the ones that you find useful. And don't do something like x equals 1, pound sign, put 1 in x. That's kind of silly. I mean, everyone can figure out what x equals 1 means. So you don't put silly comments in just for silliness. You just put them in so that you can, especially when you have to understand what's going on here, so that people don't have to read quite so detailed. And one of the things they would do is they would read this and check to see if it really did what you said it was going to do to help you debug it, for example. So that's comments. Documentation, very important. Okay. So now we're going to do our first programming code. Now, the pattern that's going to happen in here is a pattern that I call, and I was taught 25, 30, many years ago, input, processing, and output are the essential things that computers do. They gather some input, maybe from a file or from a web service. They do some work to it, and then they produce something. In, work, out. The work is the hard part, usually. And so this program is our first program that demonstrates all 3 of those things, input, processing, and output, and it's a 3-line program with 1 comment. So the problem that this program is trying to solve, for those of you who have traveled in the U.S. and traveled everywhere else, is that the ground floor in hotels in most of the world is the 0 floor, and the ground floor in the United States is the 1 floor. And so you might find yourself in a European elevator asking, what is the equivalent United States floor to this floor that I'm sitting on? So if I'm on floor 7, what would be this floor if I was in the United States? And that's the problem we're going to solve. Now, it's probably not going to make us rich if we build an app for this, but perhaps someone can get the European Elevator Converter app into some app store, and maybe you will get wealthy after all. But for now, it just is sufficient to teach us about a full-blown program that does input, processing, and output. It's as simple a program as I could make. So let's take a look at it. A comment. Convert elevator floors. That has nothing to do with Python. Has to do with you or me reading about this. Then input. Well, remember, input prints out the prompt and then pauses and waits. And then we type, and then we type the enter key, right? And then this 0, this is a string. This string ends up being put in the variable imp. And then it continues to the next line, and it works on the right-hand side. We're going to pull this string 0. We have to convert it to an integer, otherwise we can't add 1 to it. If we just int plus 1, we'd get a traceback. But we say int of imp, convert it to an integer. Now, if you mess this up and put Bob in, then this thing is going to blow up because int can't convert Bob to an integer. But because we have a 0 here, we're okay. So then we add 1 to it and store that in USF. USF, mnemonic variable name, United States floor, imp, the input we got from the user. I'm using good variable names here. So we store this in, and so we got that becomes 1, and then we print out US floor, comma, USF. Remember the comma produces this little space down here. And so we have our input, processing, and output in a way that builds us an application. Okay? Now, there's lots of things left to do, and most programs aren't one line long, and there's a lot of work that we're going to have to learn, but this gets us a start. So, we've talked a lot of stuff. We talked about constants, we've talked about variables, we've talked about reserved words, we've talked about type, we've talked about mnemonic variable names, which are both wonderful and a little confusing at the same time. Operators, operator precedence, focus a little bit on division, where we talk about Python 2 versus Python 3, type conversion and comments, and then writing an entire program. So up next, we're going to start talking about conditional execution using the if and the else and other of the reserved words. And this is where some of the intelligence starts to seem to come into computers. So up next, conditional execution.